Hello, you are welcome back to today's lesson. Today, I'm going to treat questions involving cones and frosting. Frustra is the plural of frosting. And an example of a frostum of a cone is a bucket. So we are going to start with the question on the board. A sector of a circle of radius 6 cm having an angle of 240 degrees is bent to form a cone. Full stop. Find the radius of the base of the cone and its vertical angle. Continue by trying to solve the question. Solution. Now, an example of a sector is what I have here. So we are told that this is bent to form a cone. And how can we use this to form a cone? We're going to use it to form a cone. And this radius we form what we call slant height, while the length of arc, that is this round side, we form the circular base of the cone. So watch me as I try to form the cone using this. I'll bend it like this. You can see that I have formed the cone. And this is the cone. So the arc form the circular base, while the radius form the slant height. So I'm going to draw both the sector and then the cone. So we have this. Have something like this. And then cone now. So you can see the cone. So the slant height is L, which is from here. And we are told that a sector of a circle of radius 6 cm. That means this is our L, which is the slant height, is 6 cm. 6 cm. Okay. So as I've explained, this circular face will form the base of the cone. And then this is the height. So we are going to be looking for this angle, the whole of this angle, because I have divided this into two equal parts. So in order to continue, we discover that, as I said earlier, the length of arc will form the circular base. And then that is the formula you're going to use. And that means we have the angle here from the question is 240. 240 degrees. It is bent to form this. So we are going to apply the formula. Length of arc is given by theta over 360 times 2 pi r. In this case, it will be 2 pi l because our r here, we are using L to represent it. So we have theta over 360 degrees, or let us label it A HB And then this one we can take it to be P, Q, R, S. So we are saying that length of arc AHB is equal to circumference of the base of the cone. And that means theta over 360 times 2 pi L. So instead of R, because we are using L, so that we differentiate this from this, because they are not the same, is equal to 2 pi R. That's the circumference of the base of the cone. So remember that our theta is 240. Then our L is 6. And then our pi, normally, take pi 1 to 22 over 7. Okay? So continuing, we have 240 all over 360 times 2 pi times 6 equal to 2 pi R. And if you check, you discover that we can reduce by dividing through by 2 pi. This we go. And then moving on, divide. 6 can go. This is 4. And this is 6. Again, 6 here, 1, 6 here, 1. And from this, we can see that our R is equal to 4. So our R is 4 cm. Then, since our R is 4 cm, the next thing we have to do is to find this angle and multiply by 2 to get the whole angle. And in order to do that, we consider triangle PSR. So in that, since we know the opposite to the angle, we know the hypotenuse, which is our L, it means we can just use opposite of hypotenuse, which will give us sine. So we have SR all over PR is equal to sine alpha. And that is SR is 4, and then PR is 6 all over 6 equal to sine alpha. So we check our calculator to get that. We have have 0.6667 approximately equal to sine alpha. Therefore, sine inverse alpha equal to, we check the angle that has that as the sine, and that is, go back to our calculator again. We have a sine inverse Just a minute. So after checking, it gave us sine inverse. That gave us the value is 41.81. 41.81 degrees, approximately 4 to 42 degrees. Approximately 4 to 42 degrees. So we know that, and then, but we know that the whole angle is 2 alpha. Therefore, 2 alpha is equal to 2 times 42 degrees, and that will give us 84 degrees. So, can have it that, therefore, vertical angle equal to 84 degrees. Why the radius is 4 cm. So that's the end of that question. We'll soon go over to that question number 2 on the board. Find the capacity in liters of a bucket 26 cm in diameter at the top, 18 cm in diameter at the bottom, and 22 cm deep. Take pi 4 to 20/7. So first of all, we draw the bucket. Okay, we have the bucket and the board. But before we continue, we have to complete it to be in form of a cone, because this is an example of a frustum, as I said earlier. So we have this. Um, uh, 26 diameter, 26 cm in diameter at the top. That means the radius should be 13 cm. The depth is 22 cm. And let us use x to represent this, the depth of the bigger cone. Then 18 cm at the bottom, that means the radius should be 9 cm. So we can label it A, B, C, D, E, F, G. Now, and then before we continue, we need to know the value of x. So we bring out this part, and we have something like this. Okay, so this is our 13 cm. This is 9, and then this is F, G, and this should be 22, and this is our C, this is our B, and then we have D here. So this is X. So we are going to use the idea of similar triangles to find the value of X. And the idea of some a similar triangle is smaller size, smaller side over smaller side equal to bigger side over bigger side. If you mix it up, you miss it. So let's start. That means x over 9, x, that is this side over this side, equal to x plus 22 all over 13. That is this over this equal to this plus this over this. Because this is the bigger side, we have two triangles here now. Triangle CBD and FGB. So if you cross multiply, you have 13x equal to 9 bracket x plus 22. And then open the bracket, you have 13x equal to 9x plus 9 times 22, 9, 22 by 9, we have 18, 8 carry 1, 18 plus 1, 19, 198, 198. Collect items, and that means 13x minus 9x equal to 198. So if we move on, that will give us 4x equal to 198. Therefore, x equal to 198 all over 4. And then you divide it, and you have this is 1, this is 4, that's 16. Remainder 16, remainder 3 in 38. In 38, you have 9, that's 36. That should be 0.5. So x equal to 49.5 cm. So we now continue. So remember we are trying to find the volume of the bucket. And then for us to find the volume of the bucket, it is the volume of the bigger cone minus volume of the smaller cone. Volume of the bucket equal to volume of bigger cone minus volume of smaller cone. So we'll be using capital R to represent bigger radius, and then volume of cone is 1/3 pi r squared h. That is 1/3 pi capital R squared capital H minus 1/3 pi small r squared small h, where capital R is equal to 13, capital H is equal to 49.5 plus 22. That should give us 49.5, 22. That will be 1. That will be 5. Sorry, this is 11, 1, carry 1. This is 5, 7. That's 71.5. 71.5 cm. Okay. Then small h now. Small h is 49.5. Is there another thing? No. We already know our small r. Our small r is 9. So the next thing is for us to factor out and substitute the values. And that would be 1/3 pi brackets r squared h, because 1/3 pi is common, then minus r squared h. That would be 1/3 times 22/7 into r squared should be 71.5 squared times it should be 13 squared times 71.5 minus 9 squared times 49.5. So, and that will give us, we'll continue, we have 22 all over 21, that is this. Then, handle the one in the bracket, this should be 169 times 71.5 minus 81 times 49.5. And if you check your calculator, 22/21 into, to check your calculator, we have 12,083.5, 12,083.5 minus 4009.5. 4009.5. That is after multiplying this and this. And also multiply this and this, and you have this answer, multiply this and this, and then this and this, you have this answer. So you subtract, and that will lead us to 22/21 bracket, carry out the subtraction. Going to our calculator, we have we have 1212083.5. We are subtracting 4009.5. 4009.5. That is 8074. 8074. Okay. So from here, we now carry out the multiplication and division, and you will have 177,628. We're dividing by 21, and that will give us 8458. 8458. 8458. Point 47. 0.47. 0.47. 8458.47. So, and this is a CMQ. But we are looking for the volume in liters. So 1000 CMQ equal to 1 liter. Therefore, we have to divide this by 1000 so that we convert the answer to liters. And that is 8458.47 by dividing by 1,000. And that will give us 8.45847, approximately equal to 8.5 liters. Approximately equal to 8.5 liters. So that is the answer to that. And then we are going over to number 3. Number 3, we have this: a frosting of a cone has top and bottom diameters of 14 cm and 10 cm respectively, and the depth of 6 cm. Find the volume of the cone of the frosting. We draw. Then we complete the cone. We have this as 7 cm, but diameter is 14. And then this one, 5 cm. And then let us use x to represent the height. The height here is 6 cm. Okay, so using similar triangles as usual, we have x over 5, that is this over this, is equal to x plus 6 all over 7. Cross multiply, we have 7x equal to 5x plus 30. 5 times x, 5 times 6. Collect like terms, 7x minus 5x equal to 30. 2x equal to 30. Therefore, x equal to 30 over 2, which is 15. So our x is 15. Then we are looking for the volume of the frosting. That is the volume of this upper part. So we have usual A, B, C, D, E, A, B, C, D, E, F, G, H. So in order to do that, is the usual, as usual, volume of the bigger cone minus the volume of the smaller cone. That is 1 over 3 pi capital R squared H minus 1 over 3 pi small r squared H. And that is 1 over 3, to bring pi out, r squared H minus r squared H. Here, our capital R should be 7. That would be 1 over 3 pi bracket 7 squared times. Our capital H should be, our R 7 cm, H should be 6 plus 15, which is 21 cm. Then small r is 5 cm. Small h will be 15 cm. So we move on. That should be 1 over 3 pi bracket 7 squared times 21 minus 5 squared times 15. You close your bracket, and that is 1/3 times 22/7 into 49 times 21 minus 25 times 15. And that will give us 22/21 into 49. By that will give us 1029 minus 375. And then that will give us 22/21 into, you subtract that will give you 654. That's 1029 minus 375. This will be 4. Remainder 4. This one cannot go. 12 minus 7 is 5. Remaining 9 minus 8, that's 6. 654. 654. And then move on. That will give us 20. Okay, work it out. We check our calculator to finalize. That should be 654. 654. 14388. 14388 all over 21. All over 21. And that will give us 685. 685.143. 0.143. Approximately equal to 685.14 cm3. Therefore, volume of the frost tube equal to 685.146 cm3. So that's the end of number 3, and that's the end of the lesson. Please like, share, comment, and subscribe. And if there's any question, you put it in the comment section. Thank you. I'll see you in the next video.